Okay, you're good.
All right, we good? No, I'm on mute. No, I'm not on mute. Okay. So hello, everyone that is back. I am going to be talking about refraction and reflection. And I just wanted to start with saying this is going to be some participation. I'm going to ask you some questions. So those of you that are here, if you can respond, and I'm going to write things down and we'll see how we do. Starting with refraction, the sun. When you go out during the day, what are some things you think of when that sun is hitting you? Can you give me an idea of what the sun does? Let's hear some words. Can we do chat? Oh, wait, how do you do chat?
Right there.
Where?
Top corner right there. More.
Wait, no. Stop share.
No.
Do it. Help me.
Yeah.
I'm so Zoom incompetent. There we go. Okay.
Chat.
Okay, hot and bright. Great. Anyone else? That's fine. I just moved it over a little bit. Yeah, perfect. Thank you. Big. That's a great one. What else do you think of with the sun? I'll give you a couple more to think about it. Come on, guys.
Sunny.
Okay, sun is sunny. Warm, I like that. Light and energy. Whoa, that was a good one. Light and energy, thank you. Vampire. I did not come up with that one. I like that. Anyone else? I'm gonna show you the slide of the things that I came up. So how does it? Why is it not going down? Oh man, where?
At the bottom right there. Press there.
Right that?
Or
Okay.
you can just click
Okay. So can I move this out of the way?
Just click it.
All right. These are the things that I came up with: light, heat. I'm gonna need that. Energy. No one said that one, but close. Solar flares. You know what solar flares are? When on the sun, there's like a super exertion of energy and it just spurts out. That's a solar flare. And they can affect us. Sunburn. Have you ever been out in the sun too long? Maybe in the water. Sunburn hurts your skin. A star. And hydrogen gas, because that's basically what it is. It's just a burning mass of hydrogen. Do I go this way or nope?
Just click
Where?
Just
Show
click
me.
the screen.
Really?
Anywhere.
Okay. So what we're going to be talking about is what's called the electromagnetic spectrum. It's very unique because the product is a photon. It's both a wave and a particle with mass. So it's very unique. Really nothing much has that. So electromagnetic spectrum, photon. It's a little blurry, but what you can see is this is all a photon, but it shows the difference in the wavelength. Remember, a wave can be short or it can be long. The short ones are over here on the left, the gamma rays, the X-rays, ultraviolet, then we get into the visible, infrared, microwave, and radio, long. The reason this is important is the shorter wavelengths can penetrate through walls, through anything. They're more dangerous than to life. That's why Earth is very special. If this electromagnetic energy is coming through to our planet, it can cause damage to our DNA. It can cause burns. So this is where I wanted to see if anybody can know what makes our planet so special that protects us from the dangerous radiation. Can anybody tell me a couple things, one or two? Unmute and just throw some things out or chat. Oh, beautiful. Ozone. Photon is a gauge. It does not have mass. Yeah, no, it does have mass. A photon does have mass. That's what makes it so unique. But what's protecting Earth? I've got a couple people saying ozone. Is there anything else you can come up with? Thank you. Atmosphere. And there's one more that I didn't even know about till yesterday, that it protects us. So let me just change it over. Our atmosphere, primarily nitrogen and oxygen, is what is absorbing a lot of that energy. Ozone, which is different than oxygen, because remember, oxygen's an O2, ozone's an O3. So 3 oxygen molecules. I'm not going to go into that. And we also, do you guys know what an electromagnetic field is? That's because we have an iron core to our Earth, and the Earth is spinning, and that core is spinning, and it causes an electromagnetic field around us. If you've ever heard, what's it called? The Aurora Borealis, right? Okay. If you go up real far north or south, you'll see these beautiful filtered lights. That is an electric field because of how our Earth is composed of. These 3 things together filter out the dangerous radiation that's coming from the sun, which allowed life to exist here. For whatever reason we believe it's here, it can exist. This is the only planet in our solar system because of these 3 things. So going back to our electromagnetic spectrum, we're going to look at the visible spectrum. Short is in the purples to blues, long is in the oranges to reds. Does anybody know a little mnemonic or a clue on to how to remember the order of these things? There's a word, a couple words, but how would you remember the order that these are in? It will help you forever. Anybody? Where's chat? Somebody, come on.
You already see chat right there.
Where is it?
It's the
Not rainbow, but you're close. I'm going to go, it's backwards. It's red, orange, yellow, green, blue.
That's rainbow.
No, it's not rainbow. Not rainbow. Yes.
Oh.
Somebody get it. Come on. Red, orange, yellow, green, blue, indigo, violet. Can somebody, does anybody know that one? Oh, I'm going to show you. This is a good one. Roy G BIV. You guys this is one that will carry you through all your physics and classes. Roy G BIV. Red, orange, yellow, green, blue, indigo, which is not quite violet, but then violet. Roy G BIV. Have you guys heard of this one before? Roy G BIV. No? Come on. No? Okay, please remember that one. If you take anything home right now, just turn on. Roy G BIV. So, when we go out in the sun, it's all just bright. But when light moves from one media to another, like if it's through air and then it goes through water or glass or something, it bends because what it's passing through, the medium, what it's passing through is a different density. That's called refraction. That's bending of light. So you should have this in your package. There's a couple of things that you're going to want to look at. This is called a prism. This one's glass. It could be made of something different, but I hope you all have one. That's one thing we're going to go play with in a minute. The other thing is I hope you can maybe find something made of glass. This is just a vase, but if you fill it with water, we're going to both pass a light through this, and we're going to pass the light through this. And you should be able to see light spread. So we're going to start, that's one thing we're going to do. This is, I have never been able to produce it like this. Mine is never this clear, but this is ideally what it's demonstrating. Light is passing through the prism, the crystal, and the crystal, the glass, bends it. So the sunlight will go straight through, but the diffraction, the refraction is going to go off to a side, and you're going to see the spread. And this is, we're having a beautiful day right now. We have no rain, no clouds. This is a great day we're going to go outside in a minute and practice with our prisms and see how this works in the sun. And then we're going to come back and try and find a flashlight. And we're going to try and do the same thing. So let me see, what's my next slide? Before we do that, okay, what's that? Somebody said
rainbow.
Rainbow. Why is that happening? We're bending light. So why is that happening?
Because,
go ahead.
Because then the sun goes through the rain or the moisture that's coming down still, creating the color. Excellent.
So hold on, I gotta cipher this. The sun is hitting a raindrop and it's bouncing off the backside and refracting, and it spreads it out. And that's how we get that rainbow. How about this one? Who's seen this one? What's this? Has anybody seen a double rainbow?
Nope.
Nope.
Yeah.
Nope. You've not seen it. They are gorgeous. I haven't seen many.
I've seen it.
Yeah, they're really cool. What do you see? I mean, there's a couple of things on a double rainbow that's important with refraction. What do you see on the rainbows? What do you guys observe? Is there anything special about how they are colored or how bright they are? What do you see? The bottom one is the one you would always see. The upper one is one that's unusual, and I think I've seen one triple. What do you notice that's different between these two rainbows? Anybody? It's all right. It's rain, no color. What do you notice about the colors? Somebody said colors. Let's look at the colors. Look at the bottom one first. Red, Roy G BIV. Okay, so we're going red to blue. But what do you notice about the one above it? Do you see a difference?
The other one's bigger than the other.
It is a little bit more spread, but where's the red compared to the one on the bottom?
It's opposite.
Yes. A double rainbow, they're flipped. And now on triple, it would be flipped again. And I'm going to show you the next the next image. It's going to show how it's bouncing around. But okay, so yes, it's flipped. And is it brighter or more diffuse? It's lighter. The top one is lighter because the water, as it's moving through, the energy is being removed. It's being absorbed. So every additional rainbow is going to be lighter and lighter and lighter, but they flip. And so what it looks like, this is The first one shows how if you're seeing a single rainbow, but the one over to the right, you can see how it's bouncing around in the raindrop, and that's why you're getting double image and it's flipped. I'm not going to get too complex, but I just want you to understand, if you ever see a double rainbow, look at how the images are flipped and how it gets lighter and lighter. Hopefully one day you'll see a triple. Not going to get too complex with this, but this is what happens with light. Light is passing through air and then it enters something, glass, water, a crystal, something. And Snell's law describes the relationship of how the angle as the light is hitting, and then it passes, it's bent, refraction, passes through. So don't worry, I just want you to know this exists. And if we ever want to go into it more, we can, but this just is how light is bent as it passes through another surface. And some of this, I hope you have this, I've sent a packet out to you guys. So what I want to do is give you, let's say 10 minutes. Let's go outside. Let's play. This is the prism that you all got. Did everybody get a prism? I hope everybody got a prism. What's a pot of gold? I don't know what that means. Oh, I get that. Rainbow. Got it. Did everybody get a prism? What we'll do is I want to go outside and just let you see how the light affects things.
Just one thing.
Yeah.
Why did I get a tinier one and my brother got it?
Oh, well, I don't know. You can share it.
She said.
They're
What?
just different models. Tell them that they work the same.
They work the same. My trick, I have never been able, see how there's a flat side and there's a cornered side. Remember, light is going to bend. I have not been able to make it go through the flat side and see it. But if you rotate it so that it's towards the sun on that sharp edge, then I can start bringing it in. You can try it on, you just rotate. Let's go outside. Let's go rotate it around. We can go outside. We got shoes on. Can we go out for like 10 minutes? I want you guys to see what this is because it's really neat how this works. So can we all go outside? We're all,
See, they have to go
It's
out.
Corona.
let's all go outside. I got to get my shoes on too. I want you to see what the sun does. If it works, it works. If it doesn't, it doesn't. Let's all just kind of try it and see what we get. Okay. You best is on a whitish surface. You could take the back of a piece of paper to have it flow on. But what I want, oh my God, look at who did that? That's it. That's it. You did it. Who's that?
Unpin it.
Yeah. Wait, what?
Who is that?
I'm trying to figure out the names. Ask them.
Who's doing it on the chair? Because that was it.
Ask for the name.
I don't know.
Okay, you don't have to go outside. Something's delivered.
Okay, keep talking.
Who did that? Because that worked. That was beautiful. Did you do it through your window? That was great. That was perfect.
It was me. It
It was
wasn't
me.
Daniel. He was a liar.
It
He
Was
was
Dave? Wait, who?
That was
Fatty.
Oh, Brent and Daniel, these guys, yes. That was great. Anybody else have the chance to do it?
One of them just went outside. You can see. They're
It just-
probably-
Take
Mine
it. I
didn't
mean, you
make
can
a-
play
mine
with
didn't.
it.
Mine didn't make a rainbow because it's all short. Look at that.
Mine's the same size.
Yes.
I have a longer one, but it's broken.
This
Yep,
is-
I have that one too. The size really doesn't matter. You just need it to reflect.
Give them 5 minutes to go on.
Yeah, give
Well, no, they did it through the window, which is
Oh, yeah, but
great.
some people
Mine.
But actually, I'm wondering if the window affected this also. I haven't tried it through a window. That would be kind of fun to try.
And then also, with this shorter one, I almost did magnifying glass. Almost burned down the hand.
I have a longer one. Where'd it go? It's broken, but I mean, it's not broken. It's chipped. I have one too. It's chipped, but I was able to do it with this one. And I found it worked better when I went through the sharp edge. Just pick it up and hang up. Do you guys I don't know how many people may have gone outside. Do you guys have a flashlight? Because this is another way to do it inside, and it's pretty cool. So if you have a flashlight, maybe go grab one.
Taylor says that they got it.
Okay, cool.
Just
Yeah. That's the rainbow.
Yeah.
That's what I cracked up.
Yeah.
Is it a flashlight?
Yeah, it's trying out.
Cool.
I'm just showing.
No, it's fine with me.
Um,
I don't know that there's a difference between long.
no, it's not. It's just different
Yeah.
models.
We were sent different ones.
Is that the delivery?
Yeah, that was food.
It's food.
All right, give it like 200. Continue.
So when I'm doing it, I see the outside of the flashlight, which is not the refraction. I see some light going straight through. There it is. I got mine. It's a single. See it? Oh, wow. I see blue, yellow, orange, and red. It's really hard to see it. I know, but I'm telling them I can see it.
Diana, if you tilt your camera, you might be able to put your computer camera at the paper and show people what you're seeing.
Or Alice can hold the
Yeah.
paper. Let's see how we can do this. So there's that yellow rim, that's just the flashlight. And then there's the really bright beam that's just going through. There it is. Right there. Can you see it? It's
Might be difficult to pick
Be
up.
easier if you turn off your screen share and so that you go full screen with your camera.
True.
If you're going to demonstrate
hold on. Yep, we're gonna try that.
and you say
But
something.
somebody did an awesome job already. So what I'm saying is that, man, oh man, how many do I have? I'm really refracting this. The rim on the edge is just the flashlight. The rims on the middle, that's just the flashlight. But now you start kind of, there it is. It's right there. Oh, that was a good one. I hope you can see that because this is the best I've had in a while. It's right there. So it starts with the red and the orange on top. There's definitely blue on the bottom. I have definitely refracted this light. Oh, I have a double. There's a double.
Let's continue.
So there we go. Let's give people a chance to come back. But I also want to share with you. Is everybody back, by the way? Because you can do this on your own. You don't have to do it right now.
You can continue.
So now, if you have something that's glass, you can fill this with water and do the same thing with a flashlight. I don't know if that's something if you want to do as a project right now. Do we want to try it? Do we have, no? I don't know how much time do we have? We still have plenty of time. I've got enough.
Or you can show
Do you guys have a flashlight? Because I'd love for you to try it with the flashlight just so you can see, was there a difference? Because I saw a big difference. It's something you can try, like you have this at home and you can try it later. But I saw a difference because even though this is still light, it doesn't have, it doesn't spread out the same as when you're outside in the sun. The sun is a really nice, strong bend. The flashlight has a very, very tiny bend. So it's just something you might notice. You can do it glass. I definitely recommend putting some water, just getting a clear. The more the glass bends, the worse it's going to come out. I tried it with a curved glass. I couldn't get it to work, but this is kind of thick. I wish it was thinner. It's a vase, but when it's flat edges, put water in, just lay it flat on your paper, and then you play with it, and you're going to find it. And we're just, oh my gosh, it's working even without water. It's going to come at an angle because of refraction. So let's see what we got here. Okay, so this is actually, here's where I did it. Let's see. Oh, here, it's over here. How do I move this out of the way? This is this vase filled with water, and I did a flashlight through it. You can see the flashlight's going straight through, but over to the right is where the spectrum happens, and it looks a lot better in person, but there is a definite color differentiation as it is bent through there. So that's another really, really fun kind of thing to try. I wanted to see if I could get you guys to do it. That's why I have so much time. But that is how light is bent. Another kind of fun thing, you should have a coin, a quarter in your box. And I tried this a couple of different ways. I have a cup. You don't want to use a clear cup. You want to use something you can't see through. Water is going to bend how it's seen. What you want to do is you want to put the coin at the bottom of the cup, but I've always had trouble where when I put the water in, it shifts the coin. So what I do is I put some tape at the bottom of the coin, and then I stick it at the bottom of the cup so it's not going to move. And what you want to do is you lay it at level where you just barely can't see it. You don't want to, where you can just barely peek over and see it, but you can't see it. Then you take water. This is the one on the left, is you can barely see it, right? This is exactly the same angle. So I can barely see the coin right with nothing in it, just air. Then you pour water in it. The water, now if they've taped it so that the coin doesn't move, and I pour the water in it, I can see it at the same angle where I couldn't see it, because the water is bending the light. Refraction. It's changing the direction of where the light is coming out. Does that make sense? I hope. Well, I wanted to do labs, but I'm gonna run short. So that's refraction. Refraction is bending light. It passes from air to something else, glass, water, crystal, anything else. It's passing through and it's getting bent. So now I want to just a little bit on reflection. When you think of reflection, is there something you think of, a word? I see my reflection. Hey! I see my reflection. What am I seeing? It's bouncing off of what? Come on, you can text me or chat me. reflection. I can think of a couple things. I get up in the morning, I'm brushing my teeth, I'm brushing my hair. What am I looking at? Okay, a mirror. What about, have you ever been on a lake and see the trees reflecting? So you can reflect off water. There's different ways. Refraction is bending, reflection is bouncing back. That's the difference. I love you playing with the Rubik's Cube. So reflection, when you're in the mirror and you're wearing a t-shirt and it's got a logo on it, is it the right way? Have you ever noticed that whatever your shirt is reversed in the image?
Inverted.
It is reversed, but it's not up and down, right? Like I can't tell, but I see a little, what is that called? A Yoda, baby Yoda. I wish it had like something different. If you were in a mirror, the one ear would look on the other side. Why is that? That's reflection. It's not that the mirror is actually crossing it. They're actually reflecting exactly what they see. So we're going to talk about backwards is not backwards to the mirror, and what's close is close to the mirror, and reverse is not reverse to the mirror. Where is it? So here, we did this last night. It's Alex. He's going to be working on the Rubik's Cube a little bit later. And I wish this was better, but you can, this is the picture of him in the mirror. We have a paper. Tell me that's not backwards. Is that backwards?
Backwards.
Why is it backwards? It's a camera. Okay. Oh God, I hate cameras. Okay. So this is what it would look like if he was holding it up. And then we wrote on the back so that we could do that. So if this is what it was looking like, but he held it up in the mirror, front side, it would look in reverse like this. And if you could see his shirt is actually in reverse. And then what we did was we turned it around and we got the back side. The reason is, imagine if you're holding it and looking through it. Okay, I'm looking through it. This is plastic and I'm looking through it. The mirror is seeing what's coming through it. If that makes sense. So if you have a shirt and you're looking through it, this is what you see, but this is what the mirror sees. So just like pretend you have a t-shirt on and it's got a logo. Look on the inside through it. That's what the mirror is seeing. Okay, so if we turn it around, that's what I'm seeing. I'm seeing that word now, and the mirror is seeing it correctly. So the mirror sees when you're going through it. This is, our brains just twist it around. We're so conditioned to figure it out, but that's what the mirror is doing. That's why it's this and this, but it's not this. It's not upside down. So it seems like left is right, right is left, but top and bottom is still the same. Reflection it's crazy, but it's fun. I wish I could think of something to do with mirrors. Where'd it go? Okay. We talked about left and right, but what about what's closest? Actually, before I even do that, can you guys think about when we do this, just this two-dimensional, there's a couple of things I can think of that do this in, well, I did one now with the camera. What is it about a camera that's flipping it? Remember, a lens. So what else has a lens? What are we looking with in our eyes? Our eyes have a lens, right? In the back part, middle part. They flip things around and then our brain flips it. What do astronomers use that have lenses that might flip images? And how do they, it's a good, okay, I'm testing you on this, guys. How do astronomers get around flipping the image? They use a telescope, right? A telescope has a lens. But how can you flip it back over? See if anybody can think of that one. Text me, chat, speak. What do telescopes have that flip it and then reflip it? Can you think of what would do that? When you go, has anybody gone to a store and you try on some clothes and you're in the dressing room and you have a mirror in front of you, and yes, you're reversed, but is there a way to kind of see another part? What might that dressing room have? Somebody say it. Come on, somebody chat me. Good, somebody said camera lens. I'm glad you said that. Have you ever thought about two mirrors? Have you ever looked in two mirrors and it goes back, forth, back, forth, back, forth? Those images are flipping, flipping, flipping. So telescopes get around that. They magnify, but they also will reinvert the image. Right? Why did somebody write chair? No. Mirrors. We're talking about mirrors reflect, and you can use two mirrors. So that's one way you can get around this. Lens in the eye, lens in a camera, lens in a telescope, lenses. That's think of it as like glass. Now mirrors also, what's close to you? For me, the W is furthest away from me. D is closest. But if I look in the camera right now, it's reversed. That's called the Z plane. So what I did is I set up a couple of items in front of a mirror. And what's closest to me, this bottle of honey is the closest to me, but it's the furthest away in the mirror. The puzzle is furthest from me, but it's the closest in the mirror. It flips it, but it's just representing what the information it's getting. So I should have flipped that. That would have been a good idea. It's flipped this way, but it's also flipped this way. But it's not flipping it itself. It's taking the information it's getting from reflection and bringing it right back. So refraction is a bending of light as it passes through another substance or medium, glass, water, crystal, anything like that. That's refraction, bending. And that's where you can spread out your spectrum. And I hope you can go outside. Maybe we'll do that because you have 15 minutes. You go outside with this. Reflection is how things bounce back. And just think about it. If you're looking at yourself in the mirror and it's reversed, think about why it's reversed, because it's not reversed. It's just the way you're presenting it to the mirror or the water. anything like that. So I think that was the end. I was hoping we could do our little lab stuff. Maybe next year when we're all in person, it'll be a lot more fun. But if you have any questions, chat me. Go play with, this is actually a really fun thing to play with. The prism is a really fun thing to play with. But try and do the water refraction, play with the flashlight, get some glass, see if you can break up the light, find your refraction rainbow. When I did this 2 nights ago, I got a triple rainbow. I haven't been able to do it again, but it was really, I was very excited. See if you can do it. And if you can, take a picture, we'll post it. There's just a lot of neat ways to play with this. Did you guys enjoy that? You guys did great. The ones on top, I can't believe you got that prism right away.
I'll make one suggestion when you're doing experiments with the prism and stuff. One thing that works really nicely is to actually work in a darkened room or even in a closet, because one of the things that makes it hard to see is when you have all of the other light coming in. Another thing that helps with this is if you're using a flashlight, you can use 1 or 2 pieces of cardboard and put either pinholes or slits in them so that you can get a narrow beam of light. Putting the pinhole in it will make the light not as intense, but if you're in a darker room, you can get much nicer, much clearer rainbows with that.
That's true. I took a piece of cardboard. I don't know where it is. It's around here somewhere. And I cut a slit, and then I don't even, where's the prism? Where'd it go? Here we go. And I took the prism and I laid it down in that slit. And it was a lot easier to manipulate. So that is something, I agree. That's a great suggestion. Guys, just play with it. These are, this is a one-time session, but play with it. See if you can make it work. If it's not working for you, chat with me, with Dave, Sophia, anyone, and let's see if we can help you figure it out. Because once it works and you see it, it actually is kind of exciting that it actually does work. It's very pretty. We ready for a break? Okay, I think we're ready for our break then. Dave, anything else you want to say?
Yeah, I'll just remind people of when we're up next. And so we're going to be up at 3 Mountain Daylight Time. We're still using our regular Zoom. And so we'll talk about Alex will talk about Rubik's Cube, and I'll introduce a question about slicing cubes.
Yeah, and I'm so happy that I saw some of you kind of fidgeting with the Rubik's Cube. I don't know if you're familiar with them already. But we sent you 2 Rubik's Cubes. One is a training because it has one white side and the others are dark, and then a full traditional Rubik's Cube. For those that have not done them, it's tough, but when it starts working, like when your brain starts figuring out directions and planes, that's another really neat thing. So I'm really excited that some of you are already trying to play with it. And we'll see you at 3 o'clock.